Okay, that was super quick. Thank you for that. Welcome everyone to the last workshop this year, organized by the early mid-career researchers on social network community. The first thing I want to mention, you already saw it on your desktop. The session is recorded, so we will record the session, afterwards upload it on YouTube. So please be aware of that, just in case. And then I'm super happy to introduce you to David Schoch, the workshop leader today around the topic how to work with R packages. And I'm super happy to have you here, David. You're, at least in my opinion, an expert on this topic. It couldn't be better, especially because you're also currently the team leader of the Transparent Social Analytics team at the Computational Social Science Department in Cologne. And previously, you were also connected to the Mitchell Center of Social Network Analysis at the University of Manchester. I'm sure we have some current or former members here in the audience. At the University of Manchester, you were a presidential fellow in your total research career, and that's also incredible amount of stuff. You focus a lot on technical and methodological contributions for network analysis and social network analysis. Developing further centrality measurements, working with signed networks, working with two-mode networks. And I don't want to kind of present the whole the whole life of your work, but just focusing on the points that I think are super relevant for the workshop now. I counted how many R packages you either created or contributed to, and it is over 18 R packages with in total over 2.3 million downloads on CRAN. If you're interested, David, I can send you the table I created this morning, so the data is up to date. And just to mention a small selection, David created and was part of the NetRank R package, of the SciNet package, of this SNA helper package, of the graph layouts package. But also he created two R package, which I found super interesting, which are working with the API of Tumblr, for example, and also the newest one, in the kind of context of Twitter, people leaving Twitter, the Mastodon MPI R package. I think that's incredible work, and I'm super sure you have a lot of experiences you can share with us. So it's a great pleasure for me to have you here, and I'm sure it will be a great workshop, so I'm looking forward to it. The floor is yours, David.
Thanks. Thank you very much for this nice introduction. You made me sound way more prolific than I actually am. So I'm gonna, I gave this talk a bit more, a more fun name. Okay. So I'm gonna mostly, it's split in two parts, basically, like, okay, working actually with R in your research, and also a bit on the development of R packages. If you're looking for me on social media, I usually go by this username. I think everywhere except for the Gen Z platforms like TikTok or so, if you're interested. Then also these slides are available online. Let me just do the slides are available online. So because I'm going to share a lot of resources on these slides, links to resources that might be helpful, and you can go to this website then and find these resources. So I already talked about my career, basically. I just want to maybe mention one additional thing. So my last real university employment was in Manchester until 2022, when for personal reasons we decided then, okay, we want to go back to Germany, and our kind of the natural state where my wife and I were okay, we should now apply for professorships For me, that didn't turn out too well. So I did write a lot of applications, but not even got a single interview. So that was at the first moment a bit. It was humbling, you know. You're thinking like you're on a run with your career, and then seeing, okay, actually you are not. But it also made me realize, okay, is it actually what I want to do in my life to become a professor? And I realized actually I don't want to do that. I want to do other things. And this is when I then transitioned a little bit out of at least university academia to join GESIS, which is GESIS is a social science institute that does, so most of my day I spent doing service for the research community, which means I am I help others conduct research, and part of that is obviously my work with art. And also I started R basically day one of my PhD in 2012. Before that, I did my diploma thesis with MATLAB, and I also did Fortran for a while. But I still remember my postdoc telling me, okay, you should really learn R, and that's what I basically started doing then from day one, and have not changed my language since then. I have a little confession to make. I know this is the early mid-career researcher group for network analysis, but I actually don't do much of network research anymore. Okay, it's maybe a bit too strong of a statement. I still do some network studies, but I have focusing a bit more now on open science and reproducibility. I'm going to talk about this a bit later. So what okay, my official title obviously is a team lead, but probably in academic words I would still fall under the category of a postdoc. But given that I do a lot of software development things in developing packages, I like to call myself more of a research software engineer. Sounds way better than postdoc writing our packages. I have written, someone said it, I have also counted the other day and also came around 18, 19. I think today we just finished number 19. That's not yet on here. Most of it is obviously network related, but since joining GESIS, I changed a bit also towards packages that are generally helpful for computational social science. So a lot of packages that work with APIs or other kind of mostly really data gathering packages. Now I want to start with a question. Trying to answer a question: why should I use R? So coming now from the perspective of a network scientist, the first two, open source and cross-platform, is very important. That anyone basically can use it, right? You don't need a Windows machine, you don't need a Mac or whatever. Other tools, like for instance UCINet, still mostly run on Windows, and also cost money. There is CRAN, a incredibly helpful platform where all the R packages are being kind of gathered in one place, so they're not scattered around the net, and you don't have to search too far. Reproducibility is a topic that I want to spend some more time on later, and of course it's more than just network analysis you can do, right? There are packages for all kinds of scientific endeavors, and many network studies also do need other tools. You might need to do a linear regression here and there, or logistic regression, or whatever. So it's handy if you can do all this in one place. For me, one of the biggest benefits for like R is definitely the community, which is very open, welcoming, and eager to help newcomers also. I'm going to share some places later also where you can find a lot of help for what these communities are and where you can get help when working with R. So now jumping into, you start working a bit with R, and then of course also with packages. In terms of when you work with networks, I mean, this is basically mostly for people who have not that much experience with R and network analysis. It's like, okay, there are so many packages, which ones should I actually choose to do my network analysis? And one crucial part on that is okay, which packages provide me with the proper data structures to do network analysis. Here's what this network shows you is a dependency network. So it's R packages, and the edges show dependencies among them. Blue packages depend on the package iGraph, which provides data structures for networks, then the package network in brown, and the package graph in green. So graph actually doesn't exist anymore, so the only real important network packages are actually iGraph and network. As you can see, a lot of packages, way more packages depend on iGraph. So iGraph is used a lot as kind of the base package for network analysis. iGraph is very well maintained, so they have really become a very solid community over the last few years. It's very fast, so you can use it for a lot of for large networks, and a lot of other social network analysis packages actually depend on it. So all my packages, for instance, depend on this package too as a data structure. But there are obvious reasons also to choose network, and also in conjunction with network, the SNA package, especially if you are doing ERGMs or Siena related things. So mostly in the modeling world, because iGraph does not support this, and that's the main part where you should probably switch over to the StatNet world of networks. So essentially we have the iGraph and the StatNet world, which are not really separate worlds, but you can still choose one or the other. At the end of the day, it doesn't really matter which one you choose, as long as you don't load both at the same time, because that can give you a lot of issues of compatibility or the masking of functions and so forth. So always choose one of them. This is a very one-sided view of packages in relation to network analysis, because it's mostly packages I work with. So we have, as I said, for standard network analysis, we have iGraph. If you are working with two-mode networks and are interested in projections, Backbone is a very good package for that. For signed networks, we have the package SignNet. I have one of my packages, NetUtils is basically meant to catch, to implement all types of network analysis tools that you cannot find in other packages. So from time to time, I implement new things there that I can't find anywhere. I have a large package where you can get toy data, the network data package, which is not on CRAN because it's too big to be put on CRAN. There's SNA helper is a package that I wrote a while back to facilitate, to give you the feel of a graphical interface for your analysis in R, because especially for visualization, I think it's nice to have a bit of a what you see is what you get environment to use it. And the last two are basically packages if you are into the tidyverse world and ggplot world packages to use. Obviously, this is far from comprehensive, right? And there are packages for all types of 2 weeks ago in this workshop, people were using talking about relational event models a lot. So we have also, of course, packages for that. The question is, how do you manage to find the packages you need? So first of all, you can be sure that in most cases, if you need anything in R, have any problem, you don't need to solve it by yourself, except it's coming from your research, and probably no one has solved that in R before. So a package most likely exists. Now the question is only, how do you find it? There's something that is called cron task views, which is a large list of different topic areas, machine learning, clustering, and so forth. And within these areas, you get an overview of packages that are part of it. This concept of task views is very old. It exists already since 2005, or these task views. It has been, I guess, a bit outdated for a while, but they have redesigned it in 2021 and made the process of adding stuff easier. As far as I know, there's no real like network analysis task view, but they are scattered. The packages are scattered around different topics that are related. My current favorite is actually though the R universe, which is a R package dashboard that covers all packages from GitHub. It has really grown over the last 1 or 2 years and has a lot of very nice features implemented that you get the overview. So this is, for instance, my overview of all the packages of a single maintainer. So if you know that someone has implemented a package on network analysis, you can check them out here and see if they have other packages. They have a very good search function to search for packages. As I think by now they cover everything that is on R plus everything that is not on R but an R package on GitHub that people have put on our universe. So you have to, it doesn't like look over GitHub and just randomly finds R packages. You have to take the step yourself. But I also have some resources later to show you how you can get your stuff then on our universe. There's that has also been mentioned last week. R-bloggers is a very good website, which is essentially a blog aggregator website. So a lot of people, when they have a new R package or R package version, they write a blog post about it. Many of these blogs are indexed at R-bloggers. So if you look on that website or they have a newsletter, you will also get informed about new packages. And of course, always social media, right? People always like to post about things they created on social media. If you follow people who are known to be developing our packages. If you are seeking help for specific packages, there's a series of commands in R that you can use. I mean, if you've worked with R, this will not be of anything new for you. If you have need help for a function, you do question mark function name. Many packages have inbuilt tutorials that are called vignettes, which you can check out. Okay, what kind of vignettes does a package have? And then please show me one of these vignettes. There's also always a lot of people these days do also a package down website. So package down is an R package that you can use to create to automatically create websites for your R package. So it does put you really don't have to do much. You have to essentially fill out one file, and then it automatically creates that website for you, where all the function, essentially everything that you can do here, will be shown on that website. All the help for all functions, all vignettes will be displayed in HTML and so forth. So I think it's a very nice documentation website that you can create for your R packages. And again, the mandatory self-advertisement. I have also written a lot of tutorials specifically aiming towards network analysis and network visualization. I think in the network analysis tutorial, I spend a lot, have a larger section on an overview of packages also that you can use for network analysis. Okay, so you're working now with your R packages, and you are working on your study, writing your scripts, and at one point you're done. And then it's very important, and I think George was talking about this last time too a lot, or at least he mentioned it, that you should always aim for putting your code online. So when you have written a script that is attached to a paper, you should always publish this. Now, there are a lot of excuses that people do why they wouldn't do it. Like, okay, but if I publish my script, people are going to steal my work. Like, okay, no one has time to steal your work. Everyone's busy with their own work, so no one will steal anything from you. Then, but my code is ugly. Yeah, that doesn't matter. Even if your code is ugly, no one is going to judge you or think less of you just because your code is ugly. I think my code is ugly, and I still put it online. So it is really, really important that whenever you write code that produces outcomes for your paper, that this code is online. Now, why is this important? And this is now where most of my current research is coming from, is that it helps, or it actually makes your work reproducible for others. And why is this, or what is actually reproducibility? If you're a social scientist, you probably know about the replicability crisis that has been going on in the social sciences, starting in psychology, like since in the last decade or so, that people cannot replicate the study of others or get other results or whatever. What reproducibility is actually a step before replicability. So it's defined as a result is reproducible when the same analysis steps performed on the same data set consistently produce the same answer. Okay, replicability is basically that you perform the same analysis on a different or new data set. So reproducibility is really something even more rudimentary than replicability. But in times of using computational tools for in research, this has become a very essential problem for all computational disciplines. And network analysis might not be the most computational discipline, but it certainly involves, if you do a quantitative social network analysis, a lot of computational tools. So this also is of relevance for network analysis. So we have published a paper on this recently, and we go a step further because there's a bit of ambiguity in this reproducibility definition. It lacks a verification of it. Okay, so obviously you can run your script on your own computer 10 times and you will always get the same result. That's not really what we mean by reproducibility. Reproducibility should mean that someone that is not you, that has not access to your machine, can reproduce your results. So get exactly the same results as you did in your paper. And for this, obviously, it is very essential that you share your material for that. And now, I hold or in this paper we in the first version we had a very radical statement in it. That is, if you are not willing to share your code and your data, where data is a bit of a depending on the state of the data. But if you're not willing to do this, then you should actually not publish your paper, because we view, especially in the computational disciplines, the paper is not your primary output. Your primary output is the analysis you did with the script you wrote and the results you produced from that. The paper is just advertising these results, okay? But your actual output is the script that you wrote to get the results. And that's why it's essential to always make your material that you use in your paper available for others. And just want to talk about give some examples on what the problems are in when you try to do your stuff reproducible. So we had for another paper that we wrote on this topic, we introduced an R package. The kind of difficulties you can run into if you share your material but do not put any effort in sharing it, right? You just take the script you have and just put it online. Is what we in the quote of the background below. So in essence, what it says is, depending on what version of a package you have installed on your machine and which operating system you have, you will get very different results in the analysis. So something that makes the research, the results not reproducible of that paper. Another problem that usually is like the most critical part of why scripts that people put online are not reproducible is that they have local paths in their scripts. Okay, so it starts, okay, I navigate to the folder on my machine where the data is, and then I start my analysis. The problem is that this folder, you're the only person in the world who has access to this folder, so it does not make so no one else can run this code basically other than you. Making your analysis, specifically now talking about R, reproducible is a topic that one can spend a lot of time on. But there are like 5 steps that one should consider doing when you have finished, or before you do your analysis and after you've done your analysis. So probably point 2 should actually come first. Adapt a project-oriented workflow. I have some resources on that, what I mean with that, but essentially what you should do is, for each of your papers, you create a folder that is your starting point for the project. And you always start in that. In that folder, you have then a data folder, an R script folder, a paper folder, whatever. So, and you do never in any script navigate to that folder, right? The starting point should always be this folder. This is what is meant with the project-oriented workflow. Then you should always publish your code. There's no rational reason why you should not publish your code. Nothing in code that you write is proprietary and you cannot share. What is always an issue, or what is easy an issue, is the fact that, okay, people use different versions of R packages, and there are times where an upgrade of an R package may break your script. And there is the R package called renv that helps you kind of freeze the packages that you use in your analysis. It tells people, okay, I used graph layouts package version 1.02, although there's already 1.5 out or whatever. So people know which version it is, and the benefit is also people don't have to actually install these versions. It's all handled by renv automatically. There are more steps that you can do to go even further in terms of reproducibility, but step 1 to 3 is really not that difficult to achieve. It does not require a lot of extra work from you. It's essentially probably running 1 or 2 more lines of code, and then putting your package online. So in your code online. So it is really not that difficult to make an effort to make your stuff reproducible. There are on this topic, there are a lot of resources. We also do a lot of training on this at GESIS, actually, if you're interested in that. Also important is when you use packages in your analysis, please make sure that you always cite also these packages that you are using. It's very easy to find out how you could cite R packages. So it's an R command citation graph layouts, and then you get the way you can cite a package. Very helpful tool for that is the R package grateful. What that does is if you execute one command in this, it looks into your script and recognizes which packages you use, and then automatically creates a bib text file for you that you can then just include in your paper. So that's really, really handy. And I think it's really important. I'll come to this at the end also a bit with when it's about developing our packages. It is not normal, or it's not something that's very common in science, that you would actually cite the software you are using. So this is just an example of my most used package, the graph layouts package, which has over 2 million downloads, but just 10 citations. Okay, I'm really not salty about this. It's just shows the discrepancy of how much something is used to how much it is also, I won't say appreciated, but used in a proper scientific, cited in a proper scientific way. Again, this is a long list of resources I think that are very helpful if you are working with R, but it also goes beyond the network analysis and reproducibility stuff I was talking about. Okay, I want to spend the rest of my time on now, developing R packages. So it's one thing to use R in your research, but another one is, okay, well, what are the fun things about developing R packages? Now, first question is, why should I actually care about developing an R package? It's actually the easiest way, a very easy way to share code and data only with yourself, right? If you have a lot of small functions that you use on a day-to-day basis, why not put them in a package for yourself that you don't have to copy paste functions around? Just create a package and then load that package, and then you have these functions. A lot of teams have their own internal packages that they use. This is probably more relevant for industry than it is for science. But then obviously there's everyone. So you have created a new method to analyze networks, and you want people to use it, then obviously the best way is to make it available to people. And that would be in this case an R package. But developing an R package, I remember also when I started, is kind of, it feels like a mountain in front of you. It's like, whoa, okay, am I really going to be a software developer now? But in essence, all you need to basically know about developing R package, or for developing R package, is, okay, can you use R? Do you know how you install a package? Did you ever write a function in R, or are you willing to write a function in R? If so, then you are probably able to also develop an R package, because just to make a small historic journey of myself, how I got there to the point to develop R packages. For my PhD thesis, I have written a lot of code, and should have shown a screenshot of that code because that is really bad code. And I also developed a lot of new methods in my PhD thesis, and they were scattered across these many scripts that I wrote. And I thought, okay, people might not understand what I did in my PhD, but maybe they still want to use some stuff of it. So I decided to create an R package, and I started that in 2015, and I dared to put it online 2 years later. In 2017 was my first commit in the NetRanker package. So in hindsight, way too late. And then it took me another year to decide, okay, I submit this to CRAN now. Now fast forward 6 years, right? 6 years. So the R2 package, which is the Mastodon API package, actually, it took only from the first line of code that was written till it was accepted on CRAN was just 5 days. And it is quite a big package. And it's not because I'm such an amazing developer, but I put it online before I even wrote the first line of code. And I shared on Mastodon that I'm going to write this package. And I had directly 3 or 4 other people who were willing to contribute. And we just spent 5 days doing nothing else than writing code for this package. And then we had it published. So this is what also George said 2 weeks ago. A reason to put stuff online is to get contributors or to get feedback, right? People are willing to help developing your R package. So this is kind of a takeaway message from that. Okay, never hesitate to put any code that you write online. Never be afraid of anything. No one is going to judge you because you write bad code. At least no one reasonable. And this is then also important. Okay, put your code up as quickly as possible. Also with your R package, your first R package, and even in Hadley and Jenny, two very well-known people from POSIT, say it's really not important how good your first version of an R package is. It's the only thing that is important is that the next version that you have is better. Okay, so writing an R package is constantly improving the package. No one manages to write a perfect package on first try. Actually, you never have the perfect package. You will always be working on a package. And in essence, an R package, if you boil it down, it's nothing else than it's a folder with R scripts, okay, that follow certain rules. And the good thing about this is that a lot of boring things about these rules can actually be automated. So if you use the package, use this, create package, and then the name of your package, most of these boring things are already done, and you can directly start developing your package. So it's really kind of become auto magic to create a package. And I could be now an old person, say, back in my day, we didn't have that. So I still had to, my first package was still without automating a lot of things, but these tools have made life very, very, very easy to develop R packages and actually focus on the most important stuff and not the boring side quests that you have to do when developing an R package. And again, I always come back to, okay, put your stuff out there. If you have developed any form of package, always put it on GitHub. And there's no need for you to send it to CRAN. A lot of people do not ever do it and put the packages only on GitHub. What you should do probably is though to add your account to the R universe. And the steps to do so I outlined in the link on the slides. Submitting something to CRAN is actually very tricky. Can be tricky, and there are a lot of unknown missteps one can do that I actually gathered also on this page, so this link here. So a lot of things that you wouldn't necessarily think about are gathered there. And being rejected from CRAN is not at all a bad. It's like I just the other day I had a package that I needed to resubmit 5 times or so because they always found some weird thing in it. So that's just, you know, it happens. It's less disheartening than a paper rejection, because on CRAN you can always resubmit and fix things. Journals don't necessarily allow you to do that. And since we're all academics, it's also very important to write a software paper then about it. So this is the last 8 papers that I wrote. Actually 5, the lower 5 are software papers. And again, always coming back to what George said 2 weeks ago, the Journal of Open Source Software, I think, is the most pleasant publishing experience I ever had in my career, because it's really very transparent, a very transparent review process. It's actually taking place in GitHub issues. So it's not a you submit and you wait 6 months, then you get reviews, and then you reply 6 months later, and so forth. It's an actual dialogue. So they ask a question, you can directly answer. They directly ask a question again, you answer. So it's very, as my opinion, how peer review should be. And the papers are, you have to think, okay, when you have written your R package, the main work is done, and the paper is just two pages basically. And its purpose is basically to give your R package a DOI and make it citable. So this is the most important part. So always try to write a paper about it, because this also ups your paper count then by 1, which is an important number in academia, of course. And also here's a list of resources that I think are very helpful for anyone who wants to start developing or working on developing R packages. Now, I've already hinted to this, okay? R packages are never done. So we are used to, as scientists, okay, we write paper after paper, and when we're done, we go to the next, and we forget about that paper. Maybe we cite it, but we just move on from paper to paper. But in terms of R packages or software in general, is you need to maintain these packages over time, right? Creating it is one thing, but maintaining is another. And the cool thing is always to create a package. Okay, it's like, okay, look at me, I have created this R package. But then over time you realize, okay, I need to actually maintain it. There are bugs that I need to fix, and these are really, you don't maintain a paper, right? But you do need, if there's a typo in your paper, there is a typo in your paper and in your paper. But your R packages actually need constant work. And this is kind of when I started, okay, how do I go about this? And I've started to read a lot on open source development, on software design. It's certainly not a must to do this. You can easily get away without this. But these books I actually found very helpful if you also if you're interested in going down that road a bit more. And because of this maintenance, it's very important, you know, okay, citing, this is why citing software is so important, because it's constant work. And this is from a blog post of an academic that was working a long time on a new version of a package. And he said in this was really nice, or was really resonated with me, but what he wrote in his blog post was, I could probably have published 2 academic papers instead, but would still be writing horrible code like most economists. So he kind of, if you boil it down, he sacrificed part of his academic career in order to make life for others in the economists easier. This is why I think that people who work or maintain R packages should especially academics. You shouldn't appreciate me. I'm not a real academic anymore. I do this now for a living, but other academics should get a lot of appreciation for their work. And yeah, so it is. I really like this one because it is actually the truth in most cases, that the lower right corner, that maintaining R packages is not something that it's not in your job description basically. And when I was still at university, I was doing these things then in the evening, you know, okay, I have another bug to fix, I have another bug to fix. And it's not kind of part of your day job. Or not part of your job description, let's put it that way. And also not on the radar of a lot of people that this actually is a lot of work. Also some tips. So on especially when your code is out there, right? There is, as I said, okay, you have to put your stuff out there, but there's always that comes also with a lot of negative aspects. So, for instance, okay, people will start to write you, okay, there's a bug here, there's a bug there, and it's very important to say, okay, I'm not going to respond to all these things directly, but try to work in intervals to say, okay, I'm gonna one day a month, I'm just gonna work on bugs in my R package, and then fix all these, submit it to cron again, and that's it. Because for a lot of people, I don't realize how this is a very voluntary work, and they tend, so I've experienced that myself. People tend to be rude and very like demanding. So saying, okay, please, why are you not fixing this? Please fix this. I need this, blah, blah, blah. And people come to GitHub mostly if they want to give feedback. It's always negative feedback, because okay, they report a bug, something is not working as they think. But I mean, it's called issues and not praise. Okay, so people don't go to the GitHub issues and say, well, what a nice package you have created. So this rarely happens. And you also don't know, in most cases, who actually uses your package, right? It's out there, you see, okay, 10,000 people, it has been downloaded 10,000 times, but you have no idea what people are actually doing with the package, especially if they don't cite it. So it's very important to kind of trying to stay sane in that, and trying to blend out these kind of negative aspects of package development. Okay, that was it. Slightly over time, but just a quick summary. Specifically, when it's about working with R, it's very important that you try to always publish your code for various reasons. Make sure that you always cite the packages that you're using in your paper, where there's also, okay, you don't have to cite, I don't know, a package where you use like one function. So if you use dplyr in one line of code, it's not necessarily necessary to cite the package also, but that the packages that you make heavy use of. In terms of developing R package, anyone can develop R package. So there's no, you shouldn't tell yourself, I cannot do it. Everyone can do it. It's very important to always put it online, maybe even before the first line of code is written. Write a paper about it, good for your CV. And you have to always keep in mind, okay, creating is one thing, but there's also the maintenance aspect, and that is not necessarily that much, not as much fun and rewarding as the creating is. But that's it. Thank you.
Thank you, David. Any questions from the audience? You can just unmute yourself. If not, I have a question. Sure. Maybe I can start. thank you for this great presentation. It was super interesting, especially covering a lot of things I'm currently interested in. One thing that is going maybe beyond or is tackling the R focus that you have is that based on my experience, there is this kind of development of Julia currently, where Julia is exploding in the last 2 years, 3. What is the kind of your impression? Are Julia, is R outdated, or are we still focusing on it?
Okay, so I think so. I'm a big believer of the that the future is not going to be program language X, Y, or Z, but the future is going to be program language X, Y, and Z, so that we are going to combine different programming language in the same project. A step towards that is what POSIT is doing with Quarto, for instance, where it's possible now to create documents that have R code and Python code, and I think Julia is actually also possible together in one document. So I don't think we should think in terms of which is going to be the language to use, but how can we bring these languages all together to work together, to not have a monolith, which also is a bit restrictive then to say, okay, my team only works in R, my team only does Python. No, we can work all in the language we want to, and we can combine this in our work together. So I think this is more what the future will be.
Nice, interesting, thank you. Any other question?
I have a question. Well, I have many questions, but I'm going to prioritize 2. So thank you so much, David, for that. I was wondering if you have any advice for 2 aspects. So one about ethical committed, because obviously sometimes as social scientists, we need to apply for that, and maybe they have some problems with sharing the data and that kind of stuff. So I don't know if you have any recommendations on that. And also I was wondering about collaborating with others, like if you have also recommendations for that, like how it's better to collaborate with others constructing one R package. I found amazing that you were constructing one R package in 5 days with a group of people, but maybe that also have some challenges in itself. So yeah, just that. Thank you.
Yeah, that's very good questions, and actually 2 that I would have asked myself if no one would have questions. So the first one is a very big one, and especially in computational social science, it's a very big one, because we have a lot of sensitive data from, so what we are doing at GESIS, for instance, at the moment, we are creating a web tracking tool that people install on their computer, and then it tracks the whole history of their browsing history, right? We obviously already kind of throw out banking and all these kind of things, but we still have the raw data that we want to share with researchers, and that's a big challenge, how we can do that. And there is not yet a clear solution for that, and there are these kind of someone is calling Tam, sorry. There are what did I want to say? There are these offline solutions basically to say, okay, you have to come to Cologne, you sit in this room, and then you can analyze the data, and then you are not allowed to take the data with you. But you obviously want to have this in a virtual environment somehow, okay? That people can have access to the data in a safe way without being able to actually download the data. So you can work on the data, but cannot download the data. So this is one thing. And second, in terms of reproducibility, so what we have been advocating in the paper we wrote on reproducibility is to install trusted third parties in journals. So actually some journals already started having a so-called data editor, and this data editor, what they do is they request all the material from the researcher, and then reproduce the results and then say, okay, this is reproducible with the sensitive data. And if it's really so sensitive that they are not allowed to share it, so I know at GESIS someone works who does this. They do a video call and then they walk through the script together on this video call, and then the data editor says, okay, check this is reproducible without the need of sharing the data with anyone else. So this is in terms of reproducibility, that would be the answer, but the answer to say, okay, I have a lot of sensitive data, I have sensitive data that I want to share, that's something that is not so easy to solve. The second question, collaboration. Yes, so this was for me a very big step. Also a big learning process. So GitHub is essentially made for that, right? I've been talking about it as you publish your things there, but in the end of the day, it's a platform where you collaborate on code, and it's a very different kind of thing to write a package yourself with the way you code and the way you work, than to collaborate with people. Some of them you don't even maybe know, that might have very different style of coding. So you have to kind of agree on that, and who actually works on what. So this is it becomes quickly a bit of an organizational issue, and I have basically was learning by doing, and it's best to, if you start collaborating with peers, and then figure it out. But people, the one thing is, people who want to contribute, that you don't know, they want to help you, right? They are not there to take over the package or something. They want to help you. So they probably also are willing to spend some extra effort to help you with setting up a collaboration.
Cool. Any other questions? Oh yeah, Alejandro.
So I just want to ask your opinion about something. So what is your opinion about dependency of creating a new package and having too many other packages nested in your main package? Because for example, I noticed that maybe tidyverse have this issue that if you install tidyverse, then like 20 packages, I don't know, will come up. And then if something happens in any of those sub packages, then your code will be destroyed. Or I don't know. What is your opinion on this dependency?
Yeah, that's also a very good question. And the answer is it depends. So the tidyverse is something that is by design has a heavy dependencies, because it's supposed to be, okay, this is the tool set you need, or you need to do data analysis, data science, basically. So this is the reason why this is all bundled together. So the worst thing you can do probably is when you have write your own package, you put as a dependency tidyverse in it. That's just gonna, that's wild. If you have, so let's start from what to include as a dependency. So if you use one function only from a package, then it might make sense to say, okay, I just copy that function from that package, which is a legitimate thing to do, as long as you kind of mark this clearly that, okay, this function is copied from this package. You have to, it depends on the license, of course, but all our packages have a permissive license, so that you're actually allowed to do this in various ways. And then it's a matter of deciding, or it depends if the package you depend on is also something that is a package that is well maintained. So depending on iGraph, for instance, is something that is not an issue, because that's a very well maintained package. But there are a lot of packages that are maybe not even maintained anymore. So it's very important to, if you decide, okay, this package implements stuff that I would need, to check, okay, is this actually a package that is maintained still, or is it kind of abandoned, or can I copy, in a sense of re-implement stuff that they did myself in the package. But in general, it's not too, so I'm not a purist to say, okay, your package should not depend on anything. It's totally fine to depend on a lot of things, especially when it's things that people have installed anyway. So if you depend on dplyr, chances are very high that people have that actually already installed anyway. So that's not then adding any overhead for people.
Cool. Any other question? If not, I have one. Sorry, I'm super interested in this topic. Just you mentioned it with the abundant packages, or this kind of case where a package was created 5 years ago, and even if there are issues, no updates came up. What would be your kind of walkthrough process or advice for people who found such a package, have additional functions that they created their own and would perfectly fit into this package to do? So I don't know. In my case, I wrote the creators of the package did not get any feedback, and so I'm sitting now with functions and the package which is abandoned, and I don't know.
So this is what I did with the there are two ways you can go about this. So well, what they have in common is always write them right. Are you still maintaining this? Can I if not, I'm willing to take over the package, and if you don't get a reply, then you can either, so this is what I did with there was already a Mastodon package that worked with the API, and I wrote them, but didn't get a reply. And then you have two options. A, you decide to implement the package from scratch again. They say, okay, I want to do this myself now. Or this is what you can do on GitHub is fork it. So you basically copy the package into your own GitHub repository, add your functions to it, and then you have a new version of this package. You can call it differently then, as long as you mark clearly, okay, this has been forked from this and that package. And then so this should not stop you from no reply should not stop you from doing this thing. It's always, even if they reply and say, sure, I still maintain it, but I don't want your functions, then you say, okay, well, then I fork the package and put my functions in there. So that's not a nasty thing to do. It's a very normal thing to do in open source development.
Okay, cool. Thank you. If there are no other questions, are there other questions? No. Okay, cool. Then it was a pleasure. Thank you for the presentation. It was really cool.
Thank you for having me.
It was super nice, and I'm super eager now to work on this. Cool. Nice. Francesca, do we have something else to